Welcome to video 444 of the Algebra 2 Common Core January 2017 Regents examination. We are going to do problems 25 through, I don't know, maybe 31. Let's get started. And as usual, part 2's short answers. We will start by reading the directions. Answer all 8 questions in this part. Each correct answer will receive 2 credits. Okay, if you just put the answer down without any work, you get 1 point. This happens to be out of 2, and that's nice. But if it was part 3 or 4, out of 4 points or out of 6 points, you still only get 1. Okay, so do all the work. Don't be lazy and not write something down. Write it down. All right, write it down. But in the event that you don't know how to do the work but can use the calculator, at least put it down because 1 point is better than none. Let's get started. Okay, express 1 minus I cubed in A plus BI form. Straight out algebra and easy to do. If I'm cubing something, okay, first rule of thumb. This is not equal to 1 cubed minus I cubed. Do not do that. You need to FOIL this out 3 times. You need to multiply it by itself 3 times, okay? So let's just go ahead and do that. 1 times 1 is 1. 1 times negative I, negative I. 1 times negative I, negative I. Negative I times negative I is positive I squared, okay? Second rule of thumb. I squared is negative 1. You need to remember that. So, really, this can be replaced with minus 1. And as I look at what I have here, I have a positive 1 and the negative 1. They cancel. So I'm really left with negative 2 i's. Don't forget, I still have this third thing that needs to be multiplied into. We only did 2 of them. So let's distribute. Negative 2 times 1, negative 2i. Negative 2i times a negative I is positive 2i squared. Again, I squared is negative 1. So this turns into negative 1. So I have negative 2i. A positive 2 times a negative 1 is negative 2. Now, you would receive a point off here if you left it like that. They want an A plus BI form. The number without the I must come first. The number with the I comes second. So all you've got to do is literally write your number without the I first, negative 2, then write your number with the I. And that's your final answer, and that is 100% correct. Number 26, a data and stats problem. Is that all we got? Yeah, that's it. An orange juice processing plant receives a truckload of oranges. The quality control team randomly chooses 3 pails of oranges, each containing 50 oranges. All right? So they got 3 of these. So there's a total of 150 oranges that they're going to pick up quality control. They are not going to go through the whole truckload of oranges. They're just going to pick out a random sample. Okay? Identify the sample and the population of the given scenario. All right, well, I think I kind of just gave you part of the answer. My sample is what they picked out. My sample is 150 oranges. Or in parentheses, you can put the 3 pails. 3 pails of 50. That is the sample. The population, the entire thing, is the truckload. The truckload of oranges. That's the first thing we need to do. Okay, identify the 2 things. Easy. Easy. All right? So the next thing here says, state 1 conclusion. 1. There are many. They want you to state 1. That the quality control team could make about the population if 5% of the sample was unsatisfactory, okay? If 5% of the sample was unsatisfactory, then guess what? Chances are 5% of the entire truckload is also unsatisfactory. Don't put a smiley face there. I just did. Oh, it kills me to write that much. If 5% of the sample's bad, chances are 5% of the whole truckload or the entire population is bad, okay? And you could have written that one of several different ways. And this is just one of the conclusions that you can come up with. And I think this is the most common sense one because of what they give you. 5% of the population was found to be unsatisfactory. 27. Oh, an exponential and trig. This is straight out trig because I see a trig function right here. Using the unit circle below, oh, how nice. Explain why the cosecant of theta equals 1 over y. Explain, oh, words. All right, so let's first use some math knowledge here, then explain. I know that cosecant is the reciprocal of sine, isn't it? 1 over sine. And I know in the unit circle, okay, they tell you this is the unit circle. In my unit circle, anytime I have an angle, theta, the coordinate, the x value in the coordinate, where my terminal side, that's the end of my angle, intersects the unit circle, which is this part here. The x is the cosine of theta, and the y is sine of theta. All right. Okay, well, I'm starting to see where this comes together right now. Okay? Starting to see where this comes together. Let me lower this just a little bit so I can get in and move this over here. All right? So let's do this. Okay, I know that the intersection of the terminal side of theta and the unit circle is x comma y, and y is equal to the sine of theta. Okay, the intersection of the terminal side of your angle theta and the unit circle, which is this point right here. Okay, you could have probably put that point P, and you could have said the intersection at point P, whatever, but this is just how I wrote it. So the intersection of my angle and the unit circle at this coordinate xy, y is equal to the sine of theta. That's a given. You don't have to explain that. That's a mathematical given. Okay? And since cosecant of theta equals 1 over sine of theta, therefore, cosecant of theta equals 1 over y. Because, and this is redundant, but I'm writing it again, because y equals sine of theta. Right? All we did, I mean, this is what they're going to be looking for when they grade this, okay? Number one, you got to put this together. Number two, you got to put this together. And number three, look it, if y equals sine of theta, I'm just going to substitute my y in for sine of theta and end up with this. Okay, however you want to write that, that's what they're looking for. That's the connection that they're looking for. The function m of t. Okay, here's another trig or exponential. Oh, this is an exponential. I don't see trig. I see an exponent, and it has the letter or variable t in it. Okay, the function m of t represents the mass of a radium over time t in years. Okay, and here's our equation. M of t equals 100 times e raised, this is the entire exponent here, raised to the ln of 1/2 times t all over 1590. Determine if m of t represents growth or decay. So that's the first thing I need to answer. It's one of these. And secondly, oh my goodness gracious, explain. That means words, okay? Oh boy, explain again, words. Explain your reasoning, all right? I tend to think that January exams that they give in January, in my opinion, this might not necessarily be true, but from what I've seen, they tend to be a little bit more difficult. How come? These are people that are challenging the test or retaking it because they did well in it and they want to get a better grade. So if you failed it in the previous June and you're retaking it in January, because maybe you failed it in August as well, the January test, in my opinion, tends to be a little bit harder. And the fact that you've had to explain 2 or 3 times on 2-point questions, that to me is kind of bogus. But let's do this problem. Okay, in my mind, there are 2 ways I can tell or detect whether M of t is growing or shrinking. Number 1, I'm going to either look at the graph. Okay, it's going to be some sort of graph. And chances are, I'm going to plug that in. If it's increasing, something like that, that's growth. Okay, that's G for growth, right? Or maybe it's doing something where it comes down like this. That would be D for decay. So I can look at my graph. Or I can even look at my table. Okay, as x goes from 0, 1, 2, and so forth. As x goes down, if my y increases, gets bigger and bigger, that will represent growth. If y is decreasing, it would get smaller and smaller. Okay, I can do either one. And I think I'll just look at this one for right now. Let me put that in the graphing calculator and take a look at what we got here. I love when the calculator is still on from last use, because sometimes you got to hit the on-off button 57 times. Okay, let's hit y equals. Let's clear this out. We're going to put this equation in. 100 e to the, okay, that's a fraction, so I'm going to put a fraction in the exponent. Why not? It's parenthesis, the ln of, I'm going to put 0.5 instead of 1/2. You can put 1/2, that's fine. Times t, we're going to call t x, all over 1590. Now, if I were to just look at the graph, I don't know if on a 10 by 10 graph I'm going to see anything here. And I don't. So I'm going to hit zoom fit. That tends to give me the important things here. Like maybe the x-intercept. You know, in this case, that might be the only thing. So I'm going to hit enter. And this thing is spinning here. You'll see that means it's working. There it is. And that clearly goes down. That is decreasing. All right. So you can say, you know, by looking at the graph, or if I were to look at the table, you can see how as I go down the x-axis here, my y's decrease. That also tells me it's decay. So I can choose either one of these. I'm going to use this right here. I'm going to say this is decay. That's a C. How come? I need to explain. Okay, this is the first part. You need to state this. Decay. Explain. As x increases, that means as x gets bigger and bigger. Oh, man, be careful. They don't have x here, do they? They have t. So I better make sure. I should probably put t here just to be safe. As t increases, m of t, because that's the same thing as my y, right? This is t. This is m of t. My m of t, okay, as t increases, my m of t decreases. And by definition, that is decay. All right. What about if I wanted to reference the graph? I could say, you know, looking at the graph, as the graph goes from left to right, or as t increases, my y value decreases, means it constantly has a negative slope. My line is going down into the right. It is not going up into the right. I think this is a little bit easier for explanation purposes. I mean, I suppose if I really, really wanted to, because some of my students have asked me this, if I wanted to get this t alone as the exponent, I could take 100, I take my e to the ln of 2 all over 1590 to the t. This right here is like 0.99 something, so it's 100 times 0.99 to the t. Since this value is less than 1, that also shows decreasing or decay. I could have done that as well. So there are actually, you know, multiple ways. I don't know. I like the way I did it. That seems to be the easiest method. 29, finally, a layup, okay? Sketch a cubic polynomial whose zeros are 1, 3, and -2. That's the only restriction, okay? So I'm just going to put a line here to represent my y-axis. I'm going to put a line here to represent my x-axis. And if I know anything about anything, zeros are the same thing as x-intercepts. Okay, so here's 1, 2, 3 on the x-axis. Here's -1, -2, -3 on the y-axis. All right, it has to cross at 1, at 3, and at -2. And it has to be cubic. If it's cubic, that means it has a degree 3, which means it either goes down and up, okay? Or if it's negative, that's still a cubic. It can go up, then down. It doesn't matter. I like to do this. Okay, arrow goes up, down, up. There you go, cubic. But mister, what if I wanted to go up first, I'm going to do this in blue, and come down like this, then go up and down? Guess what? That is also cubic. But mister, what if I wanted to do something that's really steep here, and I go down like this, and it goes down, and it goes way down, then comes way up, then way down? Guess what? That's also right. But mister, what if I just was something like way out here, and it came way down, and just did a little sweep like this, then it came down, bang, like that? That's fine. Everything I drew, all 4 of those different colors are correct. How come? Because they're cubics, which meaning they go in opposite directions, up and down, okay? And they went through these 3 points as x-intercepts. Okay, but let's get there you go. That is perfect. You don't have to do anything else. That's a gimme. All right, straight up algebra. Given the equal terms, cube root of x to the 5th and y to the 5/6, determine and state y in terms of x. That means y is going to equal something, blah, blah, blah. And you're going to have x's in here somewhere. You're not going to get rid of the x. They don't have an equation. They do. They tell you that these 2 terms are equal. So the first thing I'm going to do is take the cubed root of x to the 5th and make it equal to y to the 5/6. All right? And we're going to start right here. First thing I'm going to do is get rid of that radical sign. I'm going to reverse top down, bottom out here. This is my denominator. This is the numerator. If I make my radical back into an exponent, that's a fraction. If I make it back into a rational exponent, it is 5/3. That equals y to the 5/6. All right, not bad. And now I want to get rid of, I want to solve for y. I want this y to be to the power of 1, because technically that's to the 1, right? I'm just going to raise this to the reciprocal, 6/5. What's my rule? Don't I multiply exponents, raise the exponents? If I take 5/6 and multiply it times its reciprocal, 6's cancel, 1 and 1. 5's cancel, 1 and 1. 1 times 1 is 1. So I always want to multiply times my reciprocal if I have a fraction as an exponent to get rid of that rational exponent. What I do on one side, I also have to do to the other. Okay? So let's set this up. I have x to the 5/3 times 6/5, right? I got to multiply these. Just like I have to multiply these. Equals y to the 1, or which is just y. So y equals, ooh, this is nice and easy. My 5's here cancel, and I end up with 6/3. Oh, and 6/3, that's just x squared. That's it. This reduces to 2, doesn't it? It sure does. All right, let's state that y in terms of x's. Bam. Cakewalk. And number 31. All right, the final question, another layup. The results of a survey of the student body at Central High School about television viewing preferences are shown below. Okay, we have males and females. We have comedy, drama, reality. Okay, and then they give us totals, which is nice. We don't have to figure out any totals. That's the great thing about these 2-point questions. Are the events that a student is male and a student prefers reality series independent of each other? Justify your answer. Justification is not words, that's work. Show your math work, okay? There are 2 ways to prove independence. And I am going to use one of the 2 ways to prove independence, okay? Let's call this probability that a student is male. Call this the probability that a student prefers reality television, okay? In order for things to be independent, the probability of both of them multiplied together should equal the probability of both, which means and of them. So the probability of male and prefer reality television, okay? If these are equal, then yes, they are independent. If they are not equal, they are not independent, all right? So let's go ahead and do this poo-poo. All right, male. Here are the males. Boom. There are a total of 230 males out of the 490 people surveyed. So 230 out of the 490. All right. Well, let's go to the highlighter. Blue. Reality series. There are 180 out of my 490. Okay, so that's 180 out of 490. If I multiply these together, does it equal the probability of both? How many people are both male and enjoy reality series? Here's reality. Here's male. Where do they intersect? Right here. 70 out of my 490 are both male and rather watch reality series. So let's just use the calculator and get some numbers here, shall we? We shall. Let's move this here. Evansworth here. Let's use the on. Man, how many times? There we go. Let's say, how many times do you think you got to hit the on button? All right. Let's create some fractions. Let's work on the left side. We have 230 over 490. It times another fraction. And we have 180 out of 490. Yep, I should probably move down. So what happens when I hit the keys fast, children? 490. That is 414 divided by 2401. Let's get a decimal. 414 divided by 2401. Bam. So I'm going to call that 0.172. So this side is approximately did I say 472? 172. Is that equal to 70 divided by 49? No, let's take 70 and divide it by 90. 0.143, let's call it. That's approximately 0.143. They are not the same, therefore, not independent. You better state that. First of all, are the events independent? You need to answer that. Your justification, well, let's highlighter just to end this wonderful thing here. This is your justification right here. I'm gonna color until my heart smiles, and then I'm gonna color some more, and then I'll do some math. I'm sorry, I couldn't help but throw in that last thing. There you go. Not independent. There's your justification. I will see you for the next video, which will be the 5th one for our January 2017, 5th and final. And then maybe I'll try and work on the June 2017 or maybe even June 2018. Those are critical because the June exam is coming up for 2019. All right? See ya!